In this video, we are going to discuss problem based on force acting on a current carrying wire placed in a magnetic field. The question says a wire 36-meter long carries a current of 22 ampere from west to east. Find the magnetic force on the wire if the magnetic field of Earth at this location is directed from south to north and has a magnitude of 5 times 10 to the power negative 5 Tesla. So here in this question, we have a wire which is 36-meter long. So we can write the length of the wire as 36 meter. And it is carrying a current I of 22 ampere from west to east. That means it is going from west to east, which is towards the right. And it is placed in a magnetic field P of 5 times 10 to the power negative 5 Tesla. And the direction of magnetic field is from south to north. So we can show magnetic field in this direction going from south to north. And if you look at the figure, the angle between the direction of current and magnetic field is 90. So we can take the theta to be 90. We need to find what is the magnetic force F on the wire. Now magnetic force F on a current carrying wire is given as ILB sine theta. This is the magnitude of the force. Since everything is given to us in the question, let's just substitute to calculate the force. I is 22 ampere, L is 36, magnetic field is 5 times 10 to the power negative 5 into sine of the angle 90. And when you solve this, you get the force acting on the wire to be equal to 0.0396 Newton. So this is how you can find force on a current carrying wire when it is placed in a magnetic field. Now let's take up next problem. Here we have an electric power line carrying a current of 1400 ampere in a location where Earth's magnetic field is 5 times 10 to the power negative 5 Tesla. The line makes an angle of 75 degree with respect to the field. Determine the magnitude of magnetic force on a 120-meter length of the wire. So here we have electric power line carrying a current I of 1400 ampere. The Earth's magnetic field at that location B is 5 times 10 to the power negative 5 Tesla. And the wire is making an angle of theta equals 75 degree with the magnetic field. And the length of the wire is 120 meter. We need to find the magnetic force F. So again, let's substitute. We know that F is equal to ILP sine theta. I is 1400 ampere. Length of the wire is 120 meter. Magnetic field is 5 times 10 to the power negative 5 into sine of the angle theta, which is 75. When you substitute for sine here, make sure your calculator is in degree mode. And then when you solve this, you get the force F to be equal to 8.11 Newton. So these two problems were pretty straightforward, where they gave you the values of every quantities in the equation and you had to find a force. Now let's look at some problems where you will have to rearrange the term. So here you have magnetic force acting on a wire that is perpendicular to a 1.5 Tesla uniform magnetic field, and the force is 4.4 Newton. If the current in the wire is pi ampere, what is the length of the wire that is inside the magnetic field? So here I have magnetic field B of 1.5 Tesla. We have the magnetic force on the wire, which is 4.4 Newton. The current in the wire is 5 ampere, and the angle between the magnetic field and the direction of current is 90. We need to find what is the length of the wire. So we apply the same rule. We know that magnetic force on a current carrying wire in a magnetic field is given as ILB sine theta. And since theta over here is 90, sine 90 will be 1. So I can rewrite this force as just ILB. I need to find what is the length of the wire. So we will divide by I and B on both sides. And if you do not wish to rearrange, you can just substitute all the values in this expression and use shift solve. So I write length L as F over I times B. So whichever quantity you want to find, keep it as it is and divide by the terms which are left. So I'm going to divide with I and B. Now let's substitute here. F is 4.4, I is 5, B is 1.5. And when you solve this, you get the length of the wire to be equal to 0.586 meter, which you can also write as 0.59 meter. Next question. A wire carrying a 30 ampere current passes between the poles of a strong magnet that is perpendicular to its field, and it experiences a 2.16 Newton force on the 4 centimeter of a wire in the field. What is the average field strength? So here in this question, we have the current in the wire, which is 30 ampere, and it is placed between the poles of a strong magnet that is perpendicular to its field. So the angle theta is 90. It experiences a force of 2.16 Newton. The length of the wire is 4 centimeter, which is 0.04 meter. We need to find what is the magnetic field strength. So again, we write the expression for force. Force on wire is ILB sine theta. Theta is 90 and sine 90 will be 1. So we can write the force F as ILB. Now we need to find magnetic field B. So divide with I and L. So B becomes equal to F over IL. Again, you can just use shift solve here by substituting the values. So we get F equals 2.16. Current I is 30. Length of the wire is 0.04. And when you solve this, you get the strength of the magnetic field to be equal to 1.8 Tesla. Next question. A 2.5 Newton magnetic force acts on a 475 meter wire that is perpendicular to a 0.50 Tesla magnetic field. What is the current in the wire? So here we have the force acting on a wire placed in magnetic field, which is 2.5 Newton. We have the length of the wire, which is 475 meter. It is perpendicular to the magnetic field, so the angle theta is 90. Strength of the magnetic field is 0.50 Tesla, and we need to find what is the current in the wire. So again, we use the expression F equals ILB sine theta. Theta here is 90, so sine 90 will be 1. We get F equals ILB. Then we rearrange the term to find the value of current. I will divide with L and B to find I. So I will be equal to F over LB. F is 2.5. Length of the wire is 475. Magnetic field is 0.5. And when you solve this, you get the current I to be equal to 0.0105 ampere, or you can just round this off to 0.011 ampere.